Welcome to this video on the ergonomic sustainability of biomass production. Agriculture leaves behind a large ecological footprint. This also applies to biomass production. Therefore, it is necessary to consider the ecological sustainability of biomass production. Sustainability is the ability to continue a defined behavior indefinitely. For biomass production, this would mean that we can continue to produce biomass without depleting or deteriorating natural resources. This means biomass production without land degradation, without exhausting nutrient supplies such as those of phosphorus, without depleting fresh water reserves, while remaining economically and socially viable, etc. Sustainability has an ecological, economic, and social component. The trade-offs between these components often complicate decision-making. This makes it even more important to have objective and standardized instruments to measure sustainability. Scientists have developed the instrument of a life cycle analysis, including measurements of ecological footprints. A life cycle analysis is a research technique to assess environmental impacts associated with all stages of the lifetime of a product. It can be used to create an overview of all the relevant inputs and outputs or releases. This entails energy and matter associated with the production, transport, and use of a product. Such an analysis also evaluates the potential impacts of such inputs and outputs or releases. The results of such an analysis can be interpreted and used to make informed decisions. Essential elements of such a life cycle analysis are the ecological footprints. The ecological footprints are a standardized measure of human demand on the Earth's ecosystems. It represents the amount of land and sea required to supply the resources a human population consumes and to assimilate the associated waste. In the case of biomass production, it involves the land or sea, water, energy, nutrients, and chemical products used to produce biomass. But it also includes resources used to harvest, transport, store, and process the biomass. We should also take into account the impact these have on the environment. Such research often takes the shape of scenario studies. When carrying out a life cycle analysis for the primary production of biomass, several aspects are crucial. First, it is important what crop type is selected for biomass production. Second, within a crop type, there are various cultivars and they may differ substantially in their ecological footprint. This can be caused by maturity type, but also by aspects such as drought tolerance and disease resistance. And third, it is relevant to compare different crop management scenarios. To avoid competition between food, feed, and biomass, biomass crops are often grown on marginal lands. The cultivation technique needs to be adjusted to this type of land use. Ecological footprints can be converted into sustainability indicators. In the case of biomass crops, these indicators encompass, first of all, energy inputs, outputs, and use efficiencies, including indicators such as net energy output per hectare. The net energy output is the difference between energy output and energy input. Secondly, we have outputs and use efficiencies regarding greenhouse gases. A third group of indicators relate to inputs, outputs, and use efficiencies of nutrients and water. Nitrogen and phosphorus are the most important nutrients in this regard. Footprints are often expressed in global hectares per capita. The Earth has a capacity of 2.1 hectares per person. In many countries, such as the USA, Norway, Australia, the footprint is above 6.0 hectares per person. Developing countries, such as Sierra Leone, only have a footprint of 0.3 global hectares per person. Thank you for watching.